Hi everybody, my name's Byczynski. I'm the Director of Sustainable Engineering at AESG. Today I'm going to talk to you a little bit about how we can use passive design techniques to design energy efficient buildings in a Middle East context. So why passive designs? Well, as attention swings towards energy efficient and net zero buildings, passive design techniques are a really great opportunity to provide high efficiency, high performance buildings. They can allow us to reduce the energy consumption of our buildings and also the operational carbon associated with that. The added benefit is putting less equipment into buildings in the first place, reduces our embodied carbon, an area that's going to be increasingly important as we consider delivering net zero carbon buildings in the future. So what are these new and exciting technologies we can use? Well, none of them are new. What we're looking to do is we're applying old technologies that have been used for millennia in hot climates and applying them to a modern context and combining them with modern modelling technology and energy efficient equipment. So first, let's talk about building orientation. Architects have known for a long time that the most efficient way to design buildings is to locate the glazing to the north side with the solid portions facing the sun to the south and the west. Now, this can be challenging. It's difficult to argue with a client or an architect that his hotel should be facing away from the views, away from the berge, away from the sea, to minimise energy consumption in a building. But where we don't have these constraints, orientating our building in this fashion can have huge benefits at zero costs. We can also use thermal mass. Thermal mass, again, is a technique that's been used for hundreds of thousands of years. You only need to look at castles and churches in the UK and Europe. They're very cool inside when it might be very, very hot outside. And we're quite lucky in this region. We build with concrete. We build very thermally massive buildings. And we can take advantage of this using the concrete structure to absorb heat during the peak of the day. And then during the cooler portions, that heat is released. This has a number of benefits. It reduces the size of the equipment that we need to provide. And it also means that we can run our equipment at night. And if we run our equipment at night, that has the benefit of taking pressure off our utility networks. There are many areas in the UAE that struggle with power during the peak of the day during the summertime. By running our cooling equipment, which is a huge consumer of energy at night, we can take pressure off the utility networks. We can also provide something called active thermal mass, where we put chilled water or air within the concrete itself, and that massively increases the potential of that structure to absorb heat and then discharge it later. This really is just scratching the surface of what can be done with properly considered passive strategies, but we can reduce load, we can improve the stability of thermal comfort in buildings, and we can reduce both the operational and embodied carbon of our buildings. At AESG, we encourage all stakeholders, engineers, architects, developers, to prioritise these passive strategies in their projects. And by doing so, we can achieve sustainable and energy efficient buildings and ultimately can contribute to a more resilient built environment. Thank you very much for your time. If you'd like to continue the conversation, feel free to reach out to either myself or any of my colleagues, and we look forward to talking to you. Thank you.